Hello everybody, I am Paul Ducklin from Sophos Naked Security, back for another week's Naked Security live talk. Today's topic, it's an article we wrote up just this very day on Naked Security. Go and have a look if you like. It's been quite a lot in the media in the last day. It was only released yesterday, this whole story, by some researchers out of the US from a company called Sentinel-1, and they were writing about an issue to do with Macs, believe it or not, and Mac developers. And that's why today's topic is XcodeSpy, that's the name they're giving to this malware, takes aim at Mac and iOS developers. So XcodeSpy, that's the cool topic of the day. And the reason I thought it would be both fun and informative to talk about this for our Friday evening fun is that perennial thing that you hear whenever malware and Macs, or for that matter malware and Linux, or malware and Unix, or malware and anything it seems that isn't Windows comes up. You've probably met people like this. I'm sure that those watching aren't one of these people, but you've probably heard that question, and you'll see that I haven't used a question mark there. I've used an interrobang, which is an exclamation point and a question mark at the same time. Surely Macs don't get viruses! And there seems to be still these days, maybe less and less than there was, but there's still this feeling among many Mac users that there isn't that much malware for Macs. The crooks don't seem to care, so why should they care? And of course, as you probably know, it's not all about viruses and malware and stuff that could get onto your computer. It's also about things like phishing and giving away information. So it's not just about getting malware on your computer, it's the websites you go to and what they might tell you or misinform you, or the bad stuff that you might download that's not directly malware but can still put you in harm's way. But this one is rather different. It does directly affect and is directly targeted at Mac users. Now my understanding is this attack, it's not a clear and present danger as far as I know, but it does make an informative and a useful story. I believe that the original badware out of this was first seen by the Sentinel-1 guys last year, and they're kind of digging into this to find out what on earth the crooks are up to. So let me tell you a little bit of a backstory about malware in general and how we think about malware working on computers, and then let's go and look at what is specific and interesting about this XcodeSpy malware. So let's go back a few years and let's think about when we first started getting massive amounts of malware via email, or either via emails as attachments or via emails as web links that we're encouraged to click because, hey, you need this program. It's a brand new codec for the new type of video, for the particular video you want to watch. Or perhaps, hey, this is a Bitcoin calculator and investment tool. Or even just, here's a fun program which shows you how the date of Easter gets calculated. And you think, well, that seems harmless enough. You download the program, you run it, or you download the document and you open it, and there's actually some hidden software inside, and that is the malware, and the bad things happen pretty much directly. So the idea is there's a thing that you download in much the same way going back to 2001. You think the code red worm that spread so fast around the world, it was a packet that was the malware. It went across the network, it exploited a hole in your computer, it never touched disk, it just ran in memory. Exactly the same thing. The malware arrived, it was self-contained, it ran, it found the next victim, it moved on to their computer, it sat in memory in exactly the same format. So the malware, as it spread, the thing that was spreading was directly designed to contain the stuff that did the malicious activity on or around your computer. And that's pretty much how we often think of malware. It's something you bring into your network, and when it runs, then the bad stuff happens. And it's still very useful to think about malware in that way, because that's still how a lot of it works. You know, a lot of ransomware attacks, right at the end, there may be a lot of planning beforehand, but often the final file is the ransomware, and that file in its self-contained form, once it's introduced onto your network by the crooks, that is the file that when they launch it, deliberately goes out and does the bad stuff immediately. However, not all malware needs to work in that exactly direct way. So let us have a look at some examples in history where the idea is that what you introduce, the parts of it that you would look at, the parts of it that you inspect, actually look okay. And the malware is hiding in a part of what you've downloaded that will probably evade your notice because it's not what you're focused on. So you get an attachment, it's a dodgy document, you go and look in the document, oh look, the malware is clearly in there. If I open that document, the malware's inside it, the bad stuff will happen, I don't want to open it. But if we go back a few years, this is about 10 years to about 2010, some of you will remember a virus called Induc. That affected Delphi programs, but most particularly it infected or affected Delphi programmers, and they then acted as the infection vehicle for people who use their software. And it's a real problem because it didn't, the malware itself, it affected your build environment. And then every time you built or compiled a Delphi program afterwards on that build system, the program that came out was infected with the virus so you could hand it on to the next guy. But if you went and looked at the source code that you built the program from, it was absolutely unaltered. It would be absolutely unchanged because your build environment was affected. It wasn't directly infectious. It could just introduce the malware as part of the build process and you would pass it on to the next person. That was a big problem, by the way, because of course a lot of companies went, oh, we don't download software from outside. In fact, that software was designed, built, tested and digitally signed by our own in-house team, what's the chance that it could contain malware? We didn't get it from outside. And of course, the malware, the thing that delivered the infection, was already inside the network, but it was not at all obvious on the developers' computers. More recently, this is going back about 5 years, and you might want to look at this because it's kind of vaguely related to the XcodeSpy story, and it's an important way of understanding some of the different ways that malware disseminators think. This is a story about a malware called Xcode Ghost. Now, I never quite understood why people wanted to download this. It was apparently very commonly downloaded in China because it was locally hosted, so that Xcode, which is a free app from Apple, it's a massive multi-gigabyte download, and in some parts of the world, if you could download it from local servers, you get it 10 times faster. And of course, what developers who weren't thinking clearly forgot to bear in mind is that the Xcode that they downloaded from the unofficial source was nearly, but not quite the same as the one that would have come from Apple. And so what Xcode Ghost would do, exactly the same as in the Induct case, it wouldn't directly infect the developer's computer. It wouldn't actually touch the source code for the iOS, the iPhone apps that you were developing. It is when you built them, when you compiled them, ready for distribution, it would stick the malware in at that point. So you wouldn't get infected, but the next guy who got the program that you just built in your so-called trusted environment would. And that actually ended up tricking Apple into letting a whole load of compiled apps into the App Store, because the vendor's code, the components of the code that came from the vendor, when they were inspected, they were all fine. Because this thing wasn't infecting your code, it was just infecting a part of your program built from otherwise clean code. In a related sort of attack, you probably saw this article on Naked Security recently about poisoned Python packages. Now, in this case, the person was just trying to do an experiment, or he went by the name of Remind Supply Chain Risks. Not terribly grammatical, but he was uploading packages into the Python package index, into that repository. He downloaded a few with names that were similar to names that people might want to use, hoping that people would download them by mistake. And the package code was actually fine. So in other words, you're downloading a package, you think, I'm a developer. When I download a new, or when I upgrade a package, I need to be really careful that I'm not introducing malware or a Trojan horse, malicious stuff, in the source code of the package into my own source code that I will then build into my product. And of course, what they were forgetting is that things like the Python packaging system and many other environments, they don't just have code that is installed on your system that becomes part of the software that you build the packages into. They also can contain update scripts that only run at the time of update. So they're there to make sure that file permissions get set correctly and things if files need renaming and if old files need replacing or putting into temporary folders or whatever. So there are some support scripts that go along with the process of just installing or updating the package. So what you're left with after you've done the installation is exactly what you're supposed to have, because the source code of the package may have been left intact. That's what this chap had done. It was the update script where the harm was done. So it was only during the update process that the malware would attack your computer. Unfortunately, now this guy, all his code did was call home to tell him that someone had downloaded it. Presumably it was for research purposes, so he could come up with some stats. Unfortunately, instead of uploading 1 or 2 or 3 of these, getting the stats and then saying to the Python community, this is what I measured, he didn't just upload 3, he uploaded 3,951 packages. A job worth doing is worth overdoing, apparently. So that ended with, not in disaster, but with a load of unnecessary work for the Python team. But it's a big reminder through malware such as this Xcode Ghost and through these poison Python packages we wrote about just a couple of weeks ago, that it's not just the source code that you're bringing in or the software that you're bringing in and installing to use as part of your process later. It's the stuff that happens just simply to orchestrate the update. That can contain poison code as well. And so what happened in the case of this XcodeSpy, the malware wasn't in any source code that you would compile into your software. It was an Xcode package, which distributed as a zip file. Now, typically they'll contain a whole load of, if you've gone to GitHub and looked at these things, they typically contain a load of source code. It might be in Objective-C, it might be in Swift, something like that. Maybe a whole load of HTML and image files that go with it, documentation, and typically there'll be a file in there with a name, something like project.pbxproj, which is the Xcode project control file. And amazingly, this particular malware, it was one file, the project file, was modified. In fact, for some reason, the crooks left out the source code that was supposed to be in there, so it's a very tiny package. But the point is that actually installing the package did nothing at all. The malware was just sitting there waiting for later. The malware would never get built into any software that you created from the poison package. It poisoned the build process. So when you went in Xcode and you went build new release version or build new debug version, part of the build script had added 2 lines of bash code. And I'll just quickly show you what that was like. I've zoomed in a little bit there. That's some of it now. I've neatened it up and laid it out. You can see that the bash code, it was sort of scrambulated a bit, but very, very simple. It simply set a whole lot of bash variables. And if you look at if you look at some of the values there, you'll see there's a string that has the characters TCP, there's a string that has the characters ASH, ash, and then another one that ends with a B, so put those together in the right order, you'd get bash. And in fact, there's a second line of bash script that stitches those variables together in a completely randomized order. So there's no giveaway strings directly. There are no more than 3 characters at a time. They get reordered, and in the end, pretty much the malware point part boils down to something that only ever runs when you build the program. And if you only build once and then go, hey, this project is no good, I downloaded a dud, oh look, all the code's missing, I'll delete it. By then it's too late, the damage is done, because this only needs to happen once. And unfortunately it does what's called a reverse shell. Now, we spoke last week on Naked Security Live about web shells, which is where the crooks drop a file on your computer. They don't need to run it directly, they just put a web script there, and then they come back with a web browser later that triggers the script to run. Here, the crooks are dropping this script in the project file as part of the build process. And when this runs, it reaches out and gives those same crooks way into your computer. And the code, it pretty much boils down, I don't know whether you can see that, there's rather a lot of reflection. It boils down to 1 line of bash code. And this is, on a Unix or Linux system, this is about the simplest way that you can build what's called a reverse shell. And if you go to the article that we published today on nakedsecurity.sophos.com, I've actually made a little video that shows you how this works with a Mac computer being taken over by a Linux computer by running this command. And actually, you can do this. I'll just generate the shell, and then it's up to me what. I just typed in commands to prove that I was connected to your computer. If you want to try this and learn how it works yourself, you don't need a Mac and a Linux. You could do it on Windows, for example. If you want to do it with Bash, get the Unix subsystem for Windows, or you could just do it with programs like Netcat and cmd.exe on Windows. You could do it with just a Linux computer. You don't need a network. You could connect to 127.0.1 or localhost. I did it with 2 computers, but just on a local network. It's a great way of learning how easy it is to do something like this, and what the danger is when the crooks get in. And what this program does is it runs bash, which is a command shell, a command window. If you've used Mac, and well, they use Z shell now, but they still have bash there. Linux very commonly uses bash. Bash is the shell that you get in the Unix subsystem on Windows, so it's very widely used. You probably know it. You basically get a console, a terminal window, and the bash program, when you run it, generally it's connected to your keyboard for input and to your screen for output. So you can type in commands and you see the results coming back. Fantastic. That's how you drive your computer from the command line. And what this program does, if that command line does, if you see those greater than signs in there, you'll know that in bash speak or Unix speak, that means redirection. So it redirects the input and the output. So instead of connecting the bash shell, the actual command window, to your keyboard and to your screen, it actually connects to a remote TCP port, a remote server on port 443. That's HTTPS, right? TLS, secure HTTP. So most firewalls, or many firewalls, they just let that through uncontroversially, because it's meant to be this encrypted channel that's meant to improve your security, because that's where you do your web browsing. So it makes an outbound connection from the computer where the person just pressed build, and their computer's going away building, it's reading loads of files and doing lots of stuff. So you probably wouldn't notice there's one little extra command running. So it connects out to this remote computer, forges the TCP connection, runs the bash shell, and instead of connecting it to your keyboard and your screen, it connects it to the TCP connection to the network the network channel that terminates at the other end on the crook's computer. So if, at the moment that your computer just happens to run that command, they have a suitable listening process, listening for connections on port 443, it could be something as simple as netcat or ncat. It's not going to be a web server. It's just something waiting for that connection. As soon as the connection happens, they immediately have a command prompt on your computer. So they're remote, you're local, they're on your computer. They basically logged in, although the only connection your computer made was out. So there's no need for the crooks in getting in. There's no actual logging in. It was almost like you logged outwards. There's no need for the crooks to navigate their way through some weird inbound firewall security rules. They don't need a username. They certainly don't need a password. You connect to them, and that wakes up their process that says, hey, a command prompt has arrived. And even if that command shell only runs for a fraction of a second before it terminates or crashes, or the build process ends, or you'll notice that it ends with an ampersand there, which says run in the background. So everything else on your system keeps running while this is going. That as soon as it's connected, there won't be a crook sitting at the other end waiting to type in commands him or herself. There'll be some automated process that will use this command prompt, probably just once and once only, to install some new malware. Now, we don't know what that malware was, because the server that it connects to is no longer doing that. It seems to be some kind of Carder site where you can buy fraudulent credit cards these days, or that's what it's planning to be. So apparently it's not doing this command and control stuff anymore. But the guys at Sentinel-1, they took a text string out of this particular PBX proj file, and they went looking through other malware, and they found by circumstantial evidence that this curious text string that's in this malware, the XcodeSpy malware, they found it in 2 other malware samples, and they are a well-known Mac OS backdoor called eggshell. You may have heard it. If you use Sophos products, you want to go looking in your logs, we detect it as OSX/eggshell-A. We also detect this, mop this up at the same time. And the problem with this eggshell program is once that's installed on your computer, that is like super duper, it's like sort of bash on steroids. That it does things that you could do with a regular command shell by typing complicated bash commands, but it automates it all for you. And it was written as an open source project that was, for like proof of concept only, please use only on your own equipment. Of course, the crooks have not adhered to that regulation or request. And it provides sort of like single commands that instead of typing a whole sequence of Mac instructions, you can do things like take me a screenshot, grab me some passwords, run me this program, fetch me this data, sniff for these passwords and those passwords. So it's basically, it gives you all the power of the simple bash reverse shell, but with a whole lot of pre-programmed stuff. So with one single command, you can kind of do whatever you want. So that's what XcodeSpy is all about. It's malware that aims to infect Mac developers, and it aims to do it in a curious way that might not be what you're looking for. Because after all, you think, well, I'm downloading this program, this software, it's open source, maybe I don't know much about the developer. You're going to scrutinize the source code that person wrote to make sure that they're not introducing bugs or vulnerabilities or malware into the code that you're going to build into your product. And in fact, in this case, just a few lines that turn into 2 lines of bash script inside the build process means that the crooks get you to call home and give over control over your computer to them every time you build software that includes this project. So the code in the project's fine. It's the project file, the build file, that's actually dodgy. So very quickly, let's look at the advice. And some of this we said before, so I hope you don't mind me repeating this. The first thing is, don't blindly grab new or likely looking or updated versions of software packages you use for projects that you have that use lots of open source components, whether it's Swift on Apple products or Python or JavaScript or C# or whatever it is. Remember that when you update packages, not just the source code that's in the package, it's all that metadata that's in the package that causes you harm as well. So be very cautious before you introduce something new, even if you think it comes from a trusted source or looks like it comes from a trusted source, before you accept it past your test systems and into your development or even worse, your build environment. Second tip is learn about remote shells. We talked last week about web shells. This week we've talked about straight bash remote shells because they're typically very, very simple. If you think of those Hafnium attacks that we spoke about last week, the web shells that were actually using those, they were 1 line of JavaScript. In here, you saw there are basically 2 lines of bash, and one of them wasn't needed to get the remote control. It was just something else that the crooks did first. So the problem with remote shells is that the work gets done later from the outside, but 1 line of code could be enough to let you down. So make sure you learn about all of that stuff. The third tip is if you aren't filtering outbound traffic on port 443, you might want to consider doing so. Now, I know a lot of companies are uneasy about this because they feel that port 443, TLS, secure web transactions, basically they don't want to start digging inside them. They don't want to violate, if you like, the sanctity of that end-to-end encryption that's supposed to happen. Now, the good news is that if you have a firewall product with a little bit of sensitivity, I'd like to think Sophos Firewall, in my opinion, is an example of that kind of product. In our product, what you can do is you can say, okay, I'm going to designate certain types of port 443 transaction, where I'm going to known sites, such as banking sites, webmail sites, messaging sites, online payment sites, that I consider low risk. I'm going to let those go, and I'm not going to try and snoop inside. I'll just leave the end-to-end sanctity of the encryption. That will work well for everybody concerned. The user, the site at the other end, and the company won't get to see things they're not supposed to. On the other hand, if you have port 443 connections to high risk or to low reputation, completely unknown sites, then that encryption could be very much if you like, a Trojan horse or a double-edged sword to you, because with the best will in the world, there might be malicious stuff that you could otherwise stop. And of course, the other thing is if you're looking for correct connections on port 443, that when you get something like this shell that uses port 443 as a kind of loophole, as a way of sneaking out unencrypted traffic, it doesn't care about the encryption, then that just won't go through because it won't be encrypted, and the firewall can go, whoa, that's not right. It doesn't pass any of the tests. And likewise, if somebody inside your network tries to connect to a site that just hasn't got its HTTPS encryption correct, like they've messed up something on the site that means you probably shouldn't trust it, then you're not going to go there at all. The connection, you can block that connection right before you start. And the last tip, just for people at home, I would recommend, if you can, look for an antivirus that has both a malware filter that can look for bad files that arrive. Obviously, there is one in this case, and that brings in more bad files. If a bad file arrives, you'd like to know about this, but also look for an antivirus that contains a built-in web filter, because that can actually stop you going out to known bad sites in the first place, like the sites in this case, the outbound sites, they will be blocked by Sophos products as malware call home sites, so the connection just wouldn't work. So it doesn't matter whether the site's good or bad, it's known to have had a bad reputation at some point, to be associated with malware distribution, so that you don't let the connection go through and say, we'll watch this really carefully. You can just say, not going to let the connection happen in the first place. So those are my tips, folks. I've said plenty about remote shells, and to the gentleman who said last week that I looked Led Zeppelin-esque, I didn't know that was a word, but I do now. Well, I don't know whether that's really good, because, like, you know, rock and roll, or that's really bad because rock and roll